In this video, we're going to be looking at this problem, employee importance. First off, looking at the employee class, every employee has an ID, an importance value, and a list of subordinates, which is a list of other employee IDs. And for this problem, we're given a list of employees, given an integer ID, which is an employee's ID, and we want to return the total importance value of this employee and all of their direct and indirect subordinates. Let's take a look at the first example. We have employee 1 with importance 5, and they have two subordinates, employees 2 and 3. Employee 2 has importance 3, and employee 3 also has importance 3. The ID equals 1 in the input, so starting from employee 1, we want to sum up their importance and all of their subordinates' importances, which is 5 plus 3 plus 3, which equals 11. In the second example, we have employee 1 and 5, and ID equals 5 in the input. So starting from employee 5, who has importance -3, we want to sum up their importance and all of their subordinates' importance. So they don't have any subordinates, so we return -3 here. Looking at the constraints, there's one important one, which is that one employee has at most one direct leader and may have several subordinates. So keep a note of this for later on. Let's break this question down. Right off the bat, it's important to see that the employees' relationships to each other forms a graph, where the nodes are the employees and the edges are between the employees and their subordinates. But more specifically, we have a directed acyclic graph. So recall that a directed acyclic graph is a directed graph with no cycles. So this graph is directed because the subordinate relationship only goes in one direction. So if you have an employee A with a subordinate employee B, B is a subordinate of A does not imply that A is a subordinate of B. And it's acyclic precisely because A cannot be a subordinate of B. And for that matter, there aren't any cycles of subordinates. So for example, if you have A with subordinate B, and B with subordinate C, and C with subordinate D, D cannot have subordinate A. So one note here is that this is only implied by this problem. It's not stated explicitly. So the LeetCode team will probably update this problem's constraints to include that cycles cannot exist amongst these employees. Once we do build this graph, we'll start at some ID, which is some starting employee. Then all we have to do is a graph traversal, summing up the importances of the employees that we encounter. And we can do breadth first search or depth first search, it doesn't really matter. And we also don't really need to worry about cycles. So let's start working on the pseudocode. So first we create a graph from the employees, and then we BFS or DFS through the graph, summing up the importances. And that's it. So one thing here is, how do we construct the graph exactly? Well, we're given a list of employees, not necessarily in any order, and this would be a great opportunity to construct the graph via an adjacency list. So recall that an adjacency list is a mapping of nodes to their neighbors. Let's see this in action. So for example, let's say that we're given these employees. We can map from employee ID to their subordinate IDs, but then we lose out on their importance information. So instead, let's just create a hash map from employee ID to the employee object itself, like this. Now this basically functions as an adjacency list, since we still get a mapping from the employee ID to their subordinates. And say that we want to start from ID equals 1, and let's use BFS. So this means we're going to initialize a queue. And this is going to be a queue of employee IDs. Let's start off with 1. And we have a variable total, which sums up all the importances so far. So first we dequeue1. We add its importance, which is 5, to the total. Now it's 5. And then we enqueue employee subordinates, which is 2 and 3. Then we dequeue2. And then we add up its importance, which is 3, to the total. And now it's 8. And it doesn't have any subordinates. Then we dequeue3, we add up its importance to the total, so now it's 11, and it doesn't have any subordinates. And now we're done. At this point, BFS has finished its traversal and we return total, which is 11. And that's the correct answer. First, let's create a map from integer to employee. And this is going to be the map from the employee's ID to the employee object itself. For employee, and employees. So we're going to iterate through that list of employees and we're going to put their ID to the employee. And now let's start doing the BFS. So we're going to first initialize a queue. We'll first add the ID given in the input into the queue. And we're also going to have a variable total. Now while the queue is not empty, I'm going to first get the current ID from the queue. And then we can also get the associated employee with this current ID. And now let's iterate through its subordinates, adding them to the queue as well. And now we're going to increment total by the importance. At this point, we can just return total. Alright, let's run this code. And great, you'll see that it passes. And that's how you solve this problem, employee importance.